Okay, welcome you all. In the last session, we discussed the operators types. So, okay, in the last session, we discussed few operator types. In that, conditional operator we discuss, relation operator we discuss, logical operator we discuss, and assignment operator also discuss. Okay, in this session, we are going to discuss few more operators. One operator type is increment and decrement operator. Increment and decrement operators. Okay, this is a special type of operator available in C language. These operators are not available in some other languages. The operators are plus plus and minus minus. The plus plus operator is called increment operator. Increment operator. Minus minus is called decrement operator. Decrement operator. In increment operator, the value of the operand will be added by 1. The value of the operand is added by 1. Example, the value of A is equal to 10. The value of A is equal to 10. If you write plus plus A, now the value of the A will be incremented by 1. The value of the A will be added by 1. Means A is equal to 10 plus 1. A plus plus A means A is equal to A plus 1. So, we can also write it as A is equal to A plus 1 or A plus is equal to 1. Okay. This is assignment operator, this is shorthand assignment operator. Now, here the value of the A will be incremented by 1, means the operand value add by 1. Similarly, in a decrement operator, the value of the operand subtract 1. The value of the operand subtract 1 means the value of the operand will be decreased by 1. Example, A is equal to 10. If I write minus minus A, now the value of the A is equal to A minus 1, means A is equal to 10 minus 1. So, after the expression execution, the value of the A will be 9. Okay, this is the decrement operator. So, in the increment operator, the value of the operand will be added by 1, and in the decrement operator, the value of the operand subtract 1. So, here the value will be decreased by 1, here the value will be increased by 1. Okay, this increment and decrement operator we use in loop control statement. So, we use in the for loop or while loop statement for the iteration purpose. So, here increment and decrement operators are classified into two categories, that is pre-increment pre-decrement, post-increment and post decrement. post increment and post decrement. So the pre-increment example is plus plus a minus minus a plus plus a minus minus. So pre-increment and pre-decrement is plus plus a minus minus a, post increment a plus plus and a minus minus. So here we can easily observe in pre-increment and pre-decrement the operand is prefixed with plus plus and minus minus. In post increment the operand is suffixed by plus plus and minus minus. So here the value updation is different. So here we must be very careful when we performing this operation. Let's consider an example. Now my value of a is 5. Value of a is 5. Then I assign b is equal to 0 and c is equal to 10. C is equal to 10. Now my expression is b is equal to a plus plus c is equal to a plus b. A plus b. Now you observe a is equal to b is equal to a plus plus. Now this operator, increment operator, is the postfix operator. Postfix operator. Here first the value of the a will be assigned to b. First the value of a will be assigned to b. Later the value of a will be incremented by 1. Later the value of the a will be incremented by 1, means a is equal to 5 plus 1. Now the value of a is equal to 6. But in this case the value of a is added before incrementing the value. Here the value of the a will be assigned to b before incrementing the value. So now the value of the b is 5. Value of b is 5. Now c is equal to a plus b. Now a is assigned to b. After that the value of a is incremented by 1. Now the value of a is 6 and value of b is 5. Now 6 plus 5. Now c is equal to 11. Now the value of c is equal to 11. Okay, that is forced increment. So in forced increment and forced decrement, first the value of the operand will be assigned to other variable. Later the value will be updated. Similarly, if you are using b is equal to minus minus c and a is equal to b plus c. Now b is equal to minus minus c. Minus minus means decrement operator. Here decrement operator is prefixed with operand. Now this operator is pre-decrement operator. Now in this case the value of the operand c will be decremented by 1, means subtract 1, then the value will be assigned to b. Now the value of c is 11 is decrement by 1. Now the value of c is 10. 10 will be assigned to b. Next a is equal to b plus c. Now the value of b is 10. Then the value of c is 10. 10 plus 10, 20. Now a is equal to 20. Okay, this is prefix operator. So increment and decrement operators are used for adding 1 and subtract 1 from the operand value. So in increment operator, the value of the operand will be incremented by 1, means the value of the operand add by 1. So the operator is plus plus, and decrement operator is minus minus. Here the value of the operand subtract 1, means the value of the operand is decremented by 1. Okay, these two operators are unary operator. Unary operators. Okay, these operators are mainly used in loop statement or iterative statement. Okay, these operators are classified into two types: pre and post. Pre-increment, pre-decrement, post-increment and post-decrement. In pre-increment, the value of the operand incremented by 1 later assigned to the variable. In post-increment, the value of the operand will be assigned to another variable. Later, the value of the operand will be incremented. Here, in this example, b is equal to a plus plus. First, the value of the a is assigned to b. Later, the value of the a will be incremented by 1. Now, the value of a is equal to 6. In pre-increment, the value of the variable incremented first and the value will be assigned. Similarly here, example, in the decrement operator, b is equal to minus c. First, the value of the operand c, is subtracted by 1, then the value is assigned to b. Now, a is equal to b plus c, so b is equal to 10 and the value of c is decremented by 1. Now, the value of c is 10, so 10 plus 10 is 20. Okay, that is about increment and decrement operator. Okay, the next operators is a bitwise operator. Okay, the bitwise operators are the operators which manipulates data, manipulates the value at bit level. Okay, we know the computer will store data in the form of zeros and ones. So here bitwise operators mainly used for manipulating data at bit level, means binary level. Binary level means 0, 1 level. So C supports and that is bitwise and bitwise R, then bitwise XR, left shift and right shift, Okay, these are the operators are available in C language, that is bitwise and bitwise R, bitwise XR, left shift, right shift. Okay, these are the 5 operators are available in C language. First, bitwise AND operator. Okay, let's consider an example. Now I have a value A. A is equal to 8 and B is equal to 5. I will consider two value, A is equal to 8 and B is equal to 5. Now the binary equivalent, this decimal number, and binary equivalent. The binary equivalent of 8 is equal to 1, 0, 0. Then the binary equivalent of 5 is 0, 1, 0, 1, 0, 1 and 0, 1, 0, 1. So when we perform bitwise AND operation, we know the bit AND operation. In the AND operation, if two inputs are 1, then output is 1. If any one of the input is 0, output is 0. Now 0 1 0 0 0 0 0 1 0 and 1 0 0. Now the bitwise AND operation of A and B is 0 0. Similarly, if you perform OR operation, here in the bitwise OR operation, the value of the input value, if any one of the input value is 1, output is 1. If A is equal to 1, B is equal to 0, output is 1, means true. So here 0 1 1 0 0 0 0 1 1 and 1 0 is 1. 1 0 is 1. Okay, this is bitwise OR operation. So here in a bitwise AND operation 0, in bitwise OR operation the value of this is 13. The value of the bitwise OR operation of A and B is 13. So in the XOR operation, so there is a complement. If any one of the value is true, output is true. If both input is true, output is 0. So here the bitwise XOR operation is 1 1 0 1. So here also output is 13. Okay, this bitwise OR operation, bitwise AND operation and bitwise XOR operation. Okay, the next operator is left shift operator and right shift operator. So the name itself indicates the left shift operator and right shift operator. So the name itself indicates left shift operator is used to shift the bits towards left and right shift the bits towards right side. Okay. Now I'll consider the same example, that is A is equal to 8. A is equal to 8. The binary equivalent is 1 0 0 0 1 0 0. Now I'll consider this operator is left shift operator. Now I'll represent this number as by 8 bit. Okay, here in this example I represent only 4 bits. Now for shift operation I represent this by 8 bit. So 1 0 0 0 0 0 0 and 0. Okay, the value of 8 is 0 0 0 0 1 0 0. Now I'll perform left shift operation. So in the left shift operation, the value is shifted towards left by removing the right side value and appending 0 at the end of the value. Okay. Now again here in the right shift operation, the leftmost bit will be removed and left bit will be append. Append 0. Okay. Now this value is deleted. Now this value will be assigned 0 0 0 1 0 0 0 and last bit will assign with 0. Okay, this is 1 bit shifting. If in case if I shift this 2 bits, now 2 bits will be removed and 2 zeros will be appended at the end of the number. Okay, now the value of 8 become 16. So that is here the value will be double, the power will be increased. Now the value is 16. Now the value of the resultant value will be 16. Okay, now I'll consider one more example. Okay, now you consider the input. This number is 129. The value is 129. Now, if you shift this number by 1 bit, if you left shift by 1 bit, what will happen? This is 128. So, if you shift this number by 1 bit, when you do the left shift operation, the leftmost bit will be removed and rightmost bit will be assigned with 0. So, if I shift this 1 bit, now 1 will be removed, then one will be removed and 0 will be assigned with the last bit 0, 0, 0, 0, 0, 0, 1 and 0. So, 0 is appended. Append 0. Okay, now once again if I shift this number, now the value of this is 2. Now 128 become 2. Output is 2. Now if I shift this number again by 1 bit, this will be removed. This will be removed, then this will be 0, 0, 0, 0, 0 and 1, 0 and 0 will be append. Append 0. Okay, this is by shifting the number. Now the resultant value is 2 to the power 2 is 4. This is 2 to the power of 1. 2 to the power of 2. Okay, this is about shifting of the value by using bitwise operator. So, bitwise operator is bitwise left shift operator. Okay, similarly, there is one more operator. One more operator, that is right shift operator. So left shift is less than, right shift is greater than. Okay, I'll consider same number 120 129. I'll do the right shift operation, right shift. Okay, first I'll do shift by 1 bit. Okay, when I performing shift operation, left shift operation, so leftmost bit will be removed and rightmost bit will be assigned with 0. In the right shift operation, rightmost bit will be removed and leftmost bit will be assigned with 0. So here in this right shift case, the first bit will be removed. First bit will be removed, then here the value 0 is assigned here. 0, 0, 0, 0, 0, 0, 1 and 0. Append 0. Here 0 will be append. Now the resultant value is, when I shift 129 by right shift, the output will be 64. Output will be 64. Similarly, if I shift this number again, now this will be removed. Now 0, 0, 0, 0, 0, 1, 0 and 0. Append 0. Now the resultant value is 32. Here the power will be increased, here the power will be decrease. Okay, this is about the bitwise operator. So bitwise operator mainly used for manipulating the operand value at bit level, means binary level. So here we use 5 different operators: bitwise AND, bitwise OR, bitwise XOR, left shift and right shift operator. So in the left shift operator, the bit value will be shifted by towards left. In the right shift, the value shifted towards right. So in the left shift operation, the rightmost bit will be appended with 0, leftmost bit will be removed. In the right shift operation, rightmost bit will be removed and leftmost bit will be appended with 0. So here in the left shift operation, the power increased by 1. Means if you shift the number by 1 to the power of 1, if you shift the number again by 1 to the power of 2, if you shift again to the power of 3. Similarly, in the left shift operation, if the value is right shift by 1, means if in case the value power be decremented by 1. Okay, that is about the bitwise operators. The last category of operator is special operators. So special operators are star and arrow operator, comma operator and size of operator. Okay, these operators are called the special operators. Okay, here in this class we discuss these 2 operators, that is comma operator and size of operator. These operators we discuss in the later classes. Okay, this is used for pointer variable declaration. This is pointer structure pointer variable. This is address operator. Okay, now in this session we discuss these 2 operators in detail, comma operator and the size of operator. Okay, comma operators The comma operator is mainly used for linking related expression. So comma operator is mainly used for linking related expression. Example, you consider sum is equal to A is equal to 10, B is equal to 15 and A plus B. A plus B. Now you consider this as an expression. Okay, in this expression, the sub-expression A is equal to 10, B is equal to 15 and A plus B. These three sub-expressions are separated by comma. These expressions are separated by comma. Okay, here the expressions are evaluated left to right. The value will the expression will be evaluated left to right. First, the expression A is equal to 10 will be evaluated. Then the value of 10 will be assigned to A. The value of 10 will be assigned to B, A. Next, the second expression B is equal to 15. Now the value of 15 will be assigned to B. Now the value of A and B will be added. The value of A and B will be added. That is 10 plus 15. After evaluating 10 plus 15, the result will be assigned to sum. Okay. Here the comma operator is mainly used for providing link between related expressions. So comma operators operate from left to right, means the evaluation is done left to right. Okay, that is about the comma operator. The comma operator is also used in looping statement. Example, for I is equal to 0, comma, j is equal to 1, I less than 10, I plus plus, comma, j plus plus. Okay, here I is equal to 0, j is equal to 0. Okay, these two expressions evaluated. First, I is equal to 0 is performed. Later, j is equal to 1. Now, here the condition will be evaluated. After evaluating the loop, here I will be incremented by 1 and j will be incremented by 1. Now, this again I plus plus will be performed first, later j plus plus. So, these two expressions are initialization. These two expressions are increment operation. So, here the related expressions are separated by comma. So, initialization is separated by comma. Similarly, increment is also separated by comma. So, this operator is mainly used for providing link between the related expression. Okay, that is about the comma operator. Okay, the next operator is the size of operator. The size of operator is also unary operator. This operator is mainly used to know the size of operand constant data type. Size means the space occupied. Okay, to know how much space is allocated to operand, constant and data type. So, the size of operator is mainly used to know the size of the operand, constant and data types. So the size means how much memory, how much storage space is allocated for the particular operand or particular constant or data type. So to know the size, we use the operator is size of operator. It is a one word, small letter, a size D O F, size of. So within the bracket we can specify operand, constant or data type. Operand or size of constant or size of data type. Size of data type. So we can use these three to know the size. One, we can know the size of the variable or operand. We know the size of the constant. If you specify some number, you can know the size of the constant and the size of the data type. Example, size is equal to size of number. Size of number. Now you consider number is a variable. Number is a variable of type integer. If this variable is integer data type. Now if you are using a 32-bit machine, now the size of the number is 32-bit. 32-bit means 4 bytes. So the output will be 4 bytes. So the output of the size of operator in terms of bytes. Okay, if you specify size is equal to size of A. Now the character A is enclosed within pair of single quote, means it is a character constant. If you specify the character constant, then the size of this character constant is 1 byte. Now output will be 1 byte. Okay. Now this size of operator we use mainly to know the size of the array, size of the structure. Mainly used to know size of arrays and structure. Similarly, size of operator used during dynamic memory allocation. So the size of operator is used mainly to know the size of the operand, constant and data type. So here the operand may be a variables, or it may be a array variable or structure variable. So the size of operator we also use when we allocating the memory at runtime. Okay, we can use the size of operator during runtime. So it acts both compile time and runtime. So if you use to know the to identify the size of variable constant, that is the compile time. If you are using the size of operator using malloc function, then it is a dynamic operator. So during runtime, know the size of the variable, we use the size of operator. Okay, size of operator is mainly used to know the size of our memory allocated for the operand, constant and the data type. Okay, here we can also specify size is equal to size of int. Now int is a data type. Now we can also know the size of the data type. If in case if you want to know the type of machine you are using, either you are using 32-bit machine, 64-bit machine or 16-bit machine. To know the size, we can specify size is equal to size of int, because int is a word size. Int is a word size. So word size represent the machine type. So word size represent the machine type. So if you specify this size is equal to size of int, you will know the type of machine. Okay, that is about the special operators. Okay, the next topic is the arithmetic expression. So arithmetic expression is the combination of operands, operators, different types of operators. So when you are writing an arithmetic expression, we need to follow certain rules. So the expression must be end with semicolon. So when we are writing the arithmetic expression, we can also use brackets. Example, now I write an algebraic expression a plus b whole square. Okay. When you expand this, we can write a square plus b square plus 2ab. So this algebraic expression. We cannot write the same expression in C program. We need to convert this expression into C equivalent expression. So C equivalent expression is a square can be written as a into a plus b into b plus a 2 into a into b. 2 into a into b. Now this is the C equivalent of this expression. Now when you are writing this expression, we can also use bracket. A square, b square and 2 into a into b. Similarly, if in case I will write plus okay, now consider this a square plus square root of b square minus e to the power of 4 divided by b square plus c. Now this is the algebraic expression. Now we need to convert this into C expression. So first we need to evaluate this expression first. Inside, first b square, later e to the power of 4, then the result should be square root. Later the value must be subtracted by b square plus c. Then the resultant will be add with a square value. So first we need to write a into a plus a into a plus we have a function called sqrt. It's a mathematical function sqrt of b square. We can write b into b minus we have a function called power pwo power of e comma 4. Now it will calculate e to the power of 4. Okay, first this will be squared. Later, after performing the square operation, square root operation, this value will be subtracted by b into b plus c whole and whole. Okay, this is the C equivalent expression. So, when you are evaluating this expression, first innermost expression will be evaluated first, later outermost expression will be evaluated. So, first square root operation, later b square plus c operation, then the value will be added with a square value. Similarly, b square divided by a, b square divided by c. This is very simple expression. We can write this as b into b divided by c. Okay, the C equivalent expression. Okay, already mentioned, arithmetic expression is a combination of variables, constants, constant, operators. So the operator may be arithmetic operator, logical operator, bitwise operator, or relational operator. Okay, it is a combination of variable, constant, and the operators. Okay, in C language, every expression must end with semicolon. Okay, the next is the evaluation of expression. So here, left side is the variable, resultant variable, and right side is the arithmetic expression. So I already mentioned arithmetic expression is a combination of variable, constant, and operator. First, the expression will be evaluated. Later, the value will be assigned to the variable. Example, I'll write sum is equal to a into a plus b minus c. Now this is the arithmetic expression. First this expression will be evaluated, later value will be assigned. So during evaluation of expression, the C will check the precedence of the operator. So here which operator need to be evaluated, means which expression need to be evaluated. So here first a into a will be evaluated, later it add with is one, first a into a, second is a into a plus b, later the result will be subtracted with c. Okay, third, later this value is assigned to sum. At the last, the value will be assigned to sum. So the evaluation of expression will be performed from arithmetic expression evaluated left to right, then the value is assigned to left variable. So right to left assignment. So right to left is the assignment. So lowest priority is for the equal operator. First the expression will be evaluated, later the value will be assigned to the variable.